So in this video we're going to integrate an integral in which there's a cosine function that's raised to an odd positive power. And from video 1 this corresponds to guideline number 2. If the power of the cosine is odd and positive, save a cosine, convert the remaining cosines to sines using the Pythagorean identity. And just like in the previous video, video 2, the idea is to set ourselves up in a position for which we'll be able to apply a u substitution if we want to go that route. So moving over to the next slide so that I get rid of the little box and have more space. Let's start with the integral that we have. So we have cosine to the 5th power of x over, we've got a cube root of a sine function sitting there, and this is dx. And what we want to do is look at the cosine function in the numerator as being, this is to save a cosine, and that's going to leave us with a cosine to the 4th power of x. And this is the cosine we're going to save for basically to set up for a u substitution. And then we have the cube root of the sine function, which is the same as sine x to the 1/3 power, and this is dx. And then we want to look at this right here. We're going to want to use the Pythagorean identity to convert over into sines. And so remember the Pythagorean identity from trig is cosine squared plus sine squared is 1. So the cosine squared is going to be 1 minus the sine squared. And so what we need to do is look at this cosine to the 4th power as being a cosine squared getting squared. And this is the equivalent because 2 times 2 is 4. When we raise one power to another, we multiply the power. So this really is still cosine to the 4th power. But now I can replace the cosine squared inside the parentheses with 1 minus the sine squared. So drop down a line. We have cosine of x, the one that we're supposed to save for u substitution purposes. And inside the parentheses we get 1 minus the sine squared, all squared, all over sine to the 1/3 power of x. And this is dx. 1/3. My exponent's sad there. And then we need to square this guy out. So we have cosine of x, the one we're going to save, times, squaring this out, we're going to get 1. We get 1 times minus sine squared twice, so we get minus 2 times the sine squared of x. And then we get minus the sine squared times itself, so we get plus a sine to the 4th power of x all over sine to the 3rd power of x dx. And now we're in a position where we can make a u substitution if we want to. If we wanted to do a u substitution, you don't have to. You can do this integral without doing a u sub. But if you were wanting to do a u sub, you would let u equal the sine, and then du dx would equal the cosine, or in other words, du equals cosine x dx if we multiply both sides by dx. So we get du equals this. So that's why we saved this cosine right here, was for the u substitution. We can replace the cosine of x dx with du. So if we drop down one more line, we just have 1 minus 2 times the sine squared of x plus sine to the 4th power of x. Oops, I'm supposed to be doing a u substitution here. I usually integrate it without u sub. So it's going to be 1 minus 2u squared, doing the substitution u equals sine x. So 2u squared plus u to the 4th. And this is all going to be over u to the 1/3 power, u to the 3rd. And this is now a du because cosine x dx is replaced with du. And then I can actually look at this as being 3 separate terms, each over the common denominator. So I'm going to write it out explicitly, although it wouldn't be necessary to do so. We really have a 1 over u to the 1/3. And then it's going to be minus 2u squared over u to the 1/3 plus it's a u to the 4th over u to the 1/3. And this is all du. And so if we want to put this into the numerator position, we can bring u to the 1/3 up as long as we make the exponent negative. Minus, we'll get the negative 1/3, so it'll be 2u to the 2 minus a third. And 2 is really the same as 6/3 if we think about it from a common denominator perspective. So we should get u to the 6/3 minus 1/3 is 5/3 plus 4 minus a third will get u. And if we think about it from a common denominator perspective, 4 is the same as 12 over 3. So we get 12/3 minus a third is 11/3. And this is a du. And now we're in a position to integrate. So each exponent will increase by 1. So we're adding 3/3 to each exponent. Negative 1/3 plus 3/3 will be 2/3. If we differentiate this, the 2/3 would come down and not give us the coefficient of 1 that we have. So we need to kill the 2/3 with the 3/2. 3/2 times 2/3 is 1. Minus, increase this exponent by 1. So we're adding 3/3 to that, which gives us 8/3. When we differentiate, the 8/3 would come down. So we would need to kill the 8/3 with a 3/8. 3/8 times 8/3 is 1. Plus, increase this by 1, we get u. 11/3 plus 3/3 is 14/3. 14/3 would come down if we were differentiating, and so we need to kill it with the 3/14, and then it would be plus a constant of integration. And because I used u sub, I need to replace u with the sine function now. So to finish it off, we just go 3/2, sine to the 2/3 of x minus 3/8 sine to the 8/3 of x plus 3/14 sine to the 14/3 of x plus a constant of integration.